Alright, back after reading Little Blue Truck to my boy and putting him to bed. And we are coming at you now with the final polyhedron, the triangular prism. So I'm going to try to do this as quick as I possibly can. I got low battery on my iPad. We're trying to make this fast for you, okay? But it's probably going to end up being around the same length as the last one. What makes the triangular prism so tricky is that it is a different scenario, and how you do your calculations will be different dependent upon the type of triangular base that you have. We talked before about how there could be a scalene triangular base, how there could be, a equilateral triangular base, an isosceles triangular base, and also a right triangular base. And that right triangle could be isosceles or not. It doesn't matter either way. So we don't have to break it into 5 different cases. But if that isosceles triangle is a right triangle, then we'll just treat it moreover as a right triangle than we would an isosceles triangle. Okay? So here's how this is going to work. In a nutshell, how you actually reconstruct it is by creating the triangular base that you have. Now, whether that's scalene, and unfortunately, if it's scalene, we don't have any of these here. What you would have to do is literally construct your triangle with 3 segments, like so. And I know this isn't the greatest, but I'm just going to try to be quick here so you get the idea. And then you would have to copy and paste them, move them somewhere else, like we talked about with the rectangular prism, right? You want to go straight up, don't want to go straight over, go somewhere up and left or up and right or down left or down right. However far away you need it, depending upon the width, you know. If you need it way over here because it's really wide, or maybe it's really short, either way. Okay, you put it there, and then you take and connect the corresponding corners of each base. And you're going to do this regardless of whether your triangle base is scalene, as is this one, or maybe yours is isosceles based, like this, okay, or maybe yours is, try to get it close to an equilateral based one there. That's pretty darn close. Again, copy and paste and connect 3 corners, and they also have a right triangle base, something like this, okay. So these are the 4 different scenarios that you could run into. And again, we don't care if this right triangle down here is isosceles or not. It is possible, remember, for a right triangle to be isosceles, the 2 legs would be the 2 congruent ones if that's the case. The hypotenuse cannot be congruent to the legs, or cannot be congruent to any other side for that matter, but especially the legs. So here's how we're going to handle this. Depending on which one that you have, you heard me take a deep breath there, so you know what's going to be along here. Depending on the type of base that you have, that determines which measurements you're allowed to make up yourself and which ones you have to calculate. For example, let's use this scalene one right here. You are allowed to make up the length and the width and the height, which the height would be from the top of the base. It would be literally it would be the height of the base of the base triangle that it is. Okay, so we would be looking at, grab my iPad here. The width right here, the length right here, and then that's the height. Okay, and you'd be allowed to make those numbers up yourself. And I'm not going to pick numbers this time just because, again, I'm trying to save time. The ones you can't make up are these 2 slants. This slant right here, which we'll call slant number 1, and this one right here, which one we will call slant number 2. Because it's scaling, those are guaranteed to be different. So you're going to have to do 2 Pythagorean theorems to do that. Now, if you look at the front base, you can see the 2 right triangles that I'm talking about. They're created by the height part of the length and slant 1, or the height part of the length and slant 2. Here's where it gets really, really tricky. Whatever number you pick for your height, for your length, you now have to divide it, kind of proportionally based on here. Clearly, these 2 are not congruent, and they shouldn't be because this is scaling. So you have to take that full length number that you created and divide it into 2 parts of different lengths and make sure that they add up to your length. So for example, if my length was 8, I might make this 5 and I might make this 3. The reason why you have to do that is because you're going to be doing 2 completely different Pythagorean theorems. And then you would do a Pythagorean theorem here with the height that you made up and with this portion of the length that you made up, and slant 1 here being the hypotenuse. Over here, you would do, for slant 2, you would do the height as one of the legs, this little portion of the length as the other leg, and slant 2 as the hypotenuse. You would use a similar formula to what we did in the previous video about the slant 1 and slant 2 in the pyramid. Okay, it's all based off of the Pythagorean theorem, leg squared plus leg squared equals hypotenuse squared. Now once we get that S1 and S2, you can make up the length, width, and height yourself. Once you get that S1 and S2, you then will be calculating the volume. Is easy enough. You don't need S1 and S2 for that, because 2 triangular prisms of the exact same size, length, width, and height, can be smushed together to make 1 rectangular prism of that same length, width, and height. So that means it is literally half the volume of a rectangular prism with the exact length, width, and height. So it will be 1/2 times length times width times height. Easy one there. Should be very easy there. The surface area is where it becomes very, very tricky. Okay. Now, we've already talked about how to calculate slant 1 and slant 2. Once you have them, we go on from here. So I am going to write it down here, I think. The surface area is, okay, now, the surface area, if you notice, the 2 bases, again, are triangles. A triangle has a 1/2 times base times height area formula, but both of those triangles are congruent. So 2 times 1/2 is 1. They end up canceling out, leaving just the base times the height. The base of the base, I know that sounds really weird, but the base of the base, which you'll see in books and notations located as a lowercase b, as opposed to an uppercase b, which an uppercase represents the entire area of the base. So the lowercase b of the uppercase b is the length in this scenario. Okay? And the height of the base, capital B, is also the height of the lowercase b base of the triangle. Okay? Yes, I know that can be very confusing. So really all I'm trying to say is all we need to know is the length times the height. Okay? And that gives us the area of both of the triangular bases in this case. Right? Now we need to find the area of all the other faces. There are 3 other faces, and they are rectangles. Okay? This is going to bleed into the second row down here because it's quite a lengthy equation. But one of the rectangles is over on the right face, and that has a base times height, which in this case the base is the width and the height is slant 1. So we will just do the width times slant 1. Okay, we're going to add to that. Sorry that this is going onto a second row here. The left-hand face of this has a base of the width, but it has a height of the slant 2. You're having to imagine all of these as if all the faces have been broken apart and then you're in 2D now, okay? So that's the width times slant 2. And finally, the final base is like the flooring of this thing, right? And the base times height in this case would be the length times the width. So we've got the surface area equals the length times the height plus the width times slant 1 plus the width times slant 2 plus the length times the width. Okay? Wish there was a way to simplify that equation, but there really isn't because we don't have any greatest common factors to factor out of all of them at the same time. So that kind of makes things a little bit more complicated. Okay? Alright, so if you've got a scalene, then yours is done here, but you still need all the other scenarios. Final exam. Okay? I'm going to go ahead and clear everything out. And we are just going to deal with the isosceles triangle for a moment. Looks like this. Now the labels don't change. L, the length, W, the width, H, the height, they're all at the same spot, and S1 and S2 are in the same spot. It's just a matter of which ones you're allowed to create and which ones you can't create. So the nice thing about isosceles is I can go directly to the midpoint of the length, and it's perpendicular there, right? I got 5% battery on my iPad, so we better make good here real fast. Otherwise, I might have to pause this video and then start it up again later. So we got length, width, and the height. Of course, S1 is that slant, and this slant is S2. Now, the good news here is because it's isosceles, the slant 1 and slant 2 are going to be congruent. So once you found one of them, you found the other one. Bad news is there's a lot of pressure there because if you find one of them and you do it incorrectly, then the second one is also incorrect if you just assume the first one's correct. So it might be good for you to calculate both of them just to check to make sure they come out the same. This is not a project that you want to risk it and go, yeah, I got S1, S2 should be the same, and just copy it over. Okay, I've had students do that before. That's a guaranteed recipe for disaster on your surface area. The volume equation is not going to change one bit. Okay, the surface area equation is not going to change one bit either. So I don't need to re-give you those equations. And if I said earlier in the video that the equations would change, I apologize, I was wrong. Those equations stay the same. What changes is the ones that I'm able to make up and the ones that I have to calculate, okay? And the way that I have to calculate. I'm still going to make up the length, width, and height here in this one, okay? Length, width, and height I'm still going to make up myself. And I still have to calculate S1 and S2. But how I calculate S1 and S2 is slightly different from the scalene triangle in this sense. When earlier I talked about breaking up this part of the triangle to do true right triangles. This time the good news is they're congruent. So the these two right triangles here on the base should be congruent because it's an isosceles triangle. So instead of having to break this up into, let's say, 5 and 3 like I did the last time, it would be 4 and 4 this time. They're guaranteed to be congruent. And I go about the process the same way I did the scalene triangular prism. Okay? I calculate my S1 and my S2 based on that. Now, that's just a minor change. There is a big change when it comes to the equilateral triangle. Okay? Let's take a look at that one really quick. Again, the volume, the surface area equations will stay the same for all of them. It's just how we get to the things that we plug into those equations that's going to change from scenario to scenario. Okay? So here is what's different about this one. We know that equilateral means all the sides are the same. So what that means is that when I make up my length, sorry about that, let me clear all that out. When I make up my length, and I make up my width, the one that I can't make up is the height this time. Because the slant 1 here and the slant 2 have to be the same as my length. So, sorry about that too. I don't know why it's not running. There we go. The length, the slant 1 and slant 2 should all be the same number because we need them to be equilateral based, which means I have to calculate the height myself. Okay? And this is similar a little bit in concept to the last one we talked about, the isosceles, but the way you use your Pythagorean theorem is going to be different. The height still goes to the center because it is equilateral, and technically equilateral is isosceles. It's just that this time you don't know the height here. We don't know it. Right? Go down here. Right? So to find the height, we have to use the Pythagorean theorem. The good news is there's only one height for us to find. And that Pythagorean theorem we're going to use is the height is one of the legs. And if you look, what's the other leg? Well, the other leg of that right triangle there is half of the length. So this is a little bit like a pyramid, actually. Don't forget that has to be in parentheses. And that's going to equal S1 squared. Or S2 squared. It doesn't really matter because they're the same one anyway, right? So what's different here, though, is the only numbers you get to plug in are L and S1. And you're going to be calculating this H2 here. That's what's different. So you'll be using your Pythagorean theorem in a different way than you've been using it in the past because you've always used it to find S1 or S2, the hypotenuse. Now you're going to be using it to find a leg. Okay? And let's talk about the last scenario. I know I'm pushing it on battery here. Can't believe I'm actually getting through this as fast as I am. Although all of you are definitely bored. Now, what's different about the right triangular prism is that we don't have two slants now. Okay, still going to use the Pythagorean theorem. We don't have two slants, we only have one. I think you can see where it's at, right? It's right. Actually, where the S1 was previously. There. There it is. And you don't get to make it up. I mean, I suppose you could, but I don't know why you would want to. That would be silly. If you make the S up, that means one of the other dimensions you can't make up. I think it's easiest to make up the length, the width, and the height, because it's a right triangular prism, right? Right angle right there. The length and the height are the base and the height for the base, the capital B base. And we have to find the length. So what we would have to do is, you can see we're using the Pythagorean theorem where the height is one of the legs, the length is the other leg, and the slant, the only slant, is the hypotenuse. That triangle is right here. Boom. And that will help us calculate our slant. And once I have that, that goes in there. Now, I will say that the surface area equation is slightly modified. Remember, our surface area equation was this. We don't want to write with that. It was length times, it was length times height plus, and then we said width times slant 1, right? In this case, there's only one slant. Now, your instinct might be to say that we have another width times a slant, because the rest of the equation was width times slant 2. Remember, slant 2 is technically now the height. So it's width times height, actually. So S2 turns into the height, because technically the height is our slant in this one, right? And then it finishes out the same with the length times the width. So the only modification here in the right triangular prism is that the S2 turns into lowercase h, because technically the height is our slant number 2 in this case. Okay? Alrighty, folks, I know that's a lot of stuff, but you now have all the stuff to finish your project. Your project should be turned in by the end of Friday. Okay? You will spend tomorrow continuing to work on whatever polyhedrons you have left. Thursday is the same. Friday is the same. Make sure you proofread everything. You're allowed to edit the pages of your partner, meaning you can change the font size or color or whatever you want to do, but you can't do any of the typing for them, okay? And you certainly can't do any of the reconstructing of the actual polyhedrons for them either. When you are done with your project in full, and you guys have proofread it, and both of you are totally okay with it, please share that document with me, and this is important. Give me editing rights, okay? Make sure that I have editing rights, not just viewing rights or commenting rights. I need editing rights, because that is how I can verify that you did your part, your partner did their part, and nobody, did something that they weren't supposed to do for the other person. All right? Alrighty. Other than that, you guys enjoy the rest of your break, and we will see you some point in the future, Lord knows when.